Okay, today we're going to be learning more about limits, mostly algebraic techniques to solve them. I'm going to have 3 separate videos to teach this because it's a lot of material and it gives you a chance to stop, take a break and practice, and then go on. Okay, the first video is just doing analytically. It's just plug it in, direct substitution. It's highlighted in your notes. Another thing about the notes on limits, the titles of the pages are really weird. I'm going to fix them next year. Just put up with us this year. Thanks so much. Okay, direct substitution. It means if I'm taking the limit of 2x plus 5 as x approaches 3, all I do is plug 3 into my equation. So what I get is 2 times 3 plus 5, and I get 11, and that's my answer. Easy peasy, just plug it in, okay? All right, this one, there's no function there. Well, it's a constant function. It says the y value is always 10. Well, if you go back up here, it says the limit of a constant function is that constant. So the answer to this is 10. Another straight substitution. You plug it in, you get 4 minus 1 is 3, 2 cubed is 8, and that's your answer. Remember, if this had given us 0 over 0, that's called indeterminate, and you have to do something. It doesn't mean you're done, and that's what the next 2 videos are going to cover. But that's not the case here, so let's save that for another minute. Okay? Remember your trig functions. You've got to know them inside out and backwards. What's the sign at 0? Okay? Sign at 0 is equal to 0. And 0 is an acceptable answer. It's not the same as does not exist. Okay? This one, I think he had a typo. We don't need that. He uses it later on to do compositions. So all I have to do is stick -5 in here, and you get 2 for an answer. This function is dealing with greatest integer function, something we don't use very often. I don't think I ever put it on a test, but it works. This is what the graph looks like. It says if I take 1.5, the greatest integer in it is 1. If my x value is 2, the greatest integer in it is 2. So as x is approaching 2, it's coming in from the left and it's coming in from the right. Do your left and right equal? Left does not equal the right, so your limit doesn't exist, and you say DNAE, does not exist. This is an acceptable answer on the AP exam. I don't know what this is. We stole these notes from somebody. I don't know what he was talking about. So this is what I would do and not worry about it. All right, we want to take the limit of a composition. They gave you f of x is equal to x plus 7, g of x is x squared. The first thing I'm going to do is put f of x into g of x. So I end up with x plus 7 squared. Now I'm going to take the limit of that as x goes to -5. I can still just plug it in. -5 plus 7 is 2, and 2 squared is 4, and I'm done. All right. Same problem. This time we're going to -1, and you're putting g inside f. So you have x squared minus 1. That's not a 1. Hang on. I did that before. Muscle memory. Minus 1 plus 7. And you take the limit. X goes to -1. You get -1 squared is 1, minus 1 is 0, plus 7 equals 7. Done. Last one. Your turn. Find the limit if f of x is x plus 7 and g of x is x squared still. And you're going to go to -5 of f of g of x. So you're going to put this in there and get x squared plus 7. I'm taking the limit. X is going to -5. You get 25 plus 7 is 32. Something to pay attention to and to note, these are not equal, okay? It matters which way you do the composition. Keep that in mind, all right? Hope that all makes sense. If not, pause, back up, look at it again. Pretty straightforward, though. All right, the properties of limits. The first thing you got to pay attention to is, I want yellow. This right here, he left out, it should be equal to L, okay? The limit of f of x as x goes to c is equal to L. That's a typo. He forgot it. That's the guy we stole these from. and then the limit of g of x as x goes to c is equal to k. Scalar multiplication means I'm multiplying the function by a real number. Okay, a real number, doesn't matter. So your answer is that same real number times whatever the limit of f of x was. So in this case, it would be L times B. Some are different, you can add them together. And make sure that's going to C and that's going to C. So the answer here is L plus K. Oh, well, sorry, I'll read ahead. It should be L plus K. The product, you multiply them together, LK, and the quotient, it's L divided by K, assuming that K is not equal to 0. All right, those are the properties. It says find the limit as x approaches C. They told you the limit of f of x is 7 over 6 and g is 5 over 6. They want them added together, so you just add them together. 7 over 6 plus 5 over 6 gives you 12 over 6. Which is equal to 2. All right, this one they gave you equations. Determine that. I'm going to stick them together. F of x is this, 3x squared minus 2x minus 1 over x squared plus 1. And the limit as x goes to negative 1. I just plugged it in, did the math, and got 3 plus 2 minus 1 over 2. Which is 4 over 2, which is 2. Using a graph, I want to read it off of there. It says find the limit as x goes to 1 of 5 times f of x. So the limit of f of x as it approaches 1 is 1. So that's 5 times 1. This is the limit, not the y value. This is the function itself. F of 1 is 2. The bottom one, x is going to 4, comes in this way. So that limit is 2, and you have 2 squared. So 5 plus 2 is equal to 7, 2 squared is 4, and that's your answer. Okay? This one is 4 times f of x, so it's going to be 4 times the limit, which was 3/2, so that equals 6. And the last example here before we end and start our next video is a trig function. So you just plug it in. So you have the sine of pi over 2 over pi over 2. The sine of pi over 2 is 1. And then never, ever leave fraction in a fraction. So you can flip it over and you get 2 over pi. And D is your answer. Okay, that was your quick lesson on easy limits. Please continue watching. Start the next one on algebraic techniques. This is where it gets a little more complicated and your algebra skills are going to be necessary.